when I got here, we had a really like a beginning OpenStack environment. There's actually a few different OpenStack environments at Spirent when I started working here a couple months ago. And we're in the process of setting up new ones. We have to get hardware, obviously, like a lot of people do. We are doing some stuff out in the cloud, and those are coming along. But believe it or not, Spirent's been around for a long time. We have VPNs and firewalls and all sorts of things we got to get through. I have to submit help desk tickets. So we are showing a demo today of how we orchestrate the OpenStack environment using Velocity. This uses REST APIs to do the build out. Today, the OpenStack that we're using is a KVM hypervisor, and we're actually using an older Havana release of OpenStack. For those of you familiar with the release cycles, they are in alphabetical order, starting with A. We're currently, Icehouse is the one that everyone's using right now, so it's the release after Havana. So Havana is probably about a year old. And Juno is the next one that's coming out at the OpenStack Summit in Paris next month. So we're on Havana, so we might see some bugs here because of that. We are moving all of our testing in VPTC to Icehouse, and when Juno comes out, we'll be migrating to that also. So you want me to talk through it? You don't have a mic. You want to explain what's going on? You want me to do it?
You can do it.
I'll do it. Okay. We're working this part out. So this is our Velocity server here inside Spirent. What Yuji's done is she's dragged, we're going to do this again so you can see it, but she's dragged the topology from can you show the assets tab, Yuji? The virtual assets tab. We've dragged these over, and so we have a test center anywhere and test center anywhere. So anywhere client and anywhere server. And I wrote some stuff on the board over here. I wanted to kind of make this interactive. Who remembers what test center is? L47 or L23?
2.3.
Thank you. All right, so this is a layer 2.3 test. And as you can see, all we have is a virtual switch, which is the DUT. That's the device under test. And the management switch, which is what we use to communicate with the Spirent Test Center anywhere, client and server. So I wanted to also call out that we have different flavors of our products. We have obviously the physical ones, like you can see on these boards. These are the physical. Then we also have what's called virtual and anywhere. The virtual comes packaged as a virtual appliance. So you can download an OVA and put it on your VMware environment. We also have a QCOW2 image you can put on your KVM environment, and we're working on Hyper-V support. So those exist today as virtual packages. What you see here is not that. These are our anywhere packages. So anywhere is packaged as either a DEB, which is a Debian installer application, or an RPM, which is a Red Hat Package Manager installer application. And you have to provide your own virtual machine for that. So because we're doing OpenStack, we built these two Debian boxes, and we put the Spirent Test Center Anywhere application on those two boxes. They're actually stored in a Glance repo. Since none of you are using OpenStack no one's using OpenStack, come on.
At home, maybe.
One person, okay. Two people. You guys know what Glance is?
Repository of images.
Yeah, perfect. So OpenStack is the umbrella project name for a number of other projects. And basically it's Red Hat and NASA and Rackspace started OpenStack because one of them was working on a storage project and the other was working on a compute virtualization project, and they decided to put the two together and they called it OpenStack. So now they have all these other projects that are part of OpenStack, and they're adding more and more. Seems like every day, it seems like. But Glance is where we put these images, and then Spirent Test Center, iTest, aka Velocity is the new name for iTest, is taking the images out of Glance and putting them on the OpenStack environment. So we've provisioned this topology. We've built the virtual switches, and I don't know if you can see the writing. The DUT, which is the device under test network, is 10.0.1, so that's a /24 network. And then the management network is 10.155. So that's how we're communicating to it. And the test traffic is going to go over the DUT network.
So I've actually already replicated the topology on OpenStack.
Okay.
I'll get you a microphone if you wouldn't mind. You want to click one on or just hold one?
I'll just hold one.
Okay.
Can you hear me?
Yeah, it's being recorded and streamed out. So
Okay. Yeah. So
I don't know if anyone else can hear you though.
Okay, what I was trying to say is that I've already activated this topology, basically launched it and replicated in OpenStack. So this is too big. Yeah,
so we have a small screen for the projector, but if she scrolls around a little bit, you'll see that this is the actual OpenStack server where the topology has been built. So like Paul was mentioning, you draw the topology out like Visio, and then you can deploy it. And so once it's deployed, OpenStack will show you this in their dashboard. So it's basically a replica of the environment as it's built.
Right. And you can also see the 2 STC virtual machines that are online, right? They're instances that are brought online. So now I think I'll try to run a test case. So wish me luck.
I should mention this product is still being released. Okay, so we're attaching the ports for the test. Okay.
It's basically just layer 2 traffic going from source to the destination. And you see that there's a little bit of a packet loss, which is, I guess, normal on OpenStack.
Reassuring.
So while she's doing that, I like this test because we're going to be moving it into different environments. So today, the test is all on one hypervisor. So basically, we have the box with the hypervisor, and we're testing across a vSwitch. But this same test could be done across 2 hypervisors, and you can have the test go through the physical network and back up. And so that would give you a great test of whatever kind of tunneling protocols you're using between the hypervisors.
So can you have some control over that, of what other physical elements you can put in there?
Sure. Well, yeah, you would obviously have to obtain the hardware. That's where we're going. So there are cloud options for that. We're using a colo provider in San Jose called Nefoscale. Or if you're doing it here in your lab, you go and get a couple old boxes, whatever, Cisco UCS, HP, whatever hardware you want, and you plug it in. And then when you deploy once you have that hardware built, then you come to your iTest velocity solution and you deploy that topology. So you do your dragging, and then that's where I mentioned Glance because those images that you're deploying are coming from the Glance repo. And so the STC Anywhere images, or if you're using virtual, also Avalanche Anywhere images or virtual, are living in this Glance repo. And when you deploy with iTest, it takes them out and pushes them out over here. So you do have control over that, especially if you're using OpenStack. They have hypervisor groups and availability zones. And so you can decide which availability zone you put your virtual machines in. If you wanted to do a mixed hypervisor test, you could have one, say the client go on VMware, and if you're looking at going to KVM or Hyper-V, you could have the server be on the Hyper-V, and then you could do a test that way.
Have you seen big performance gaps in testing different virtual switches?
Of course, yes.
Really?
Yeah, so that's one of the reasons why we set up the virtual cloud test lab, the VCT lab, and why we're doing this VPTC. We've had customers already coming to us saying that they've done their own testing, but they're not sure if they're doing it right. So this reference architecture allows everyone to sort of be on the same level playing field. We're using the same versions of everything. We're doing the same configuration. It's kind of validated. And now we have a common ground where you can go and run your product's tests. So we have vendors actually paying us to do testing of their products in this environment. And they're like, how does the other company's product work in the same environment? And I'm like, well, it's your lab. You can do what you want with it. It's your private lab. So you run your tests. You have your results. You take that information back to your competitive marketing team or whoever you want and do it. But we're obviously, not going to do those tests and share that data just for public. Now, for open source stuff, I think there is a value to do that for the community. So when it comes to testing new versions of Open Virtual Switch, anything that's open source, we're going to be pulling that in. We don't have it today, but that's on our roadmap. That's why we're here talking to you, is we're investing heavily in the open source community. And we will be automating this as part of our CI pipeline. We wanted to get you guys the word out first. This was an opportunity that came to us to have you guys here and share that message with you. And hopefully get some of your feedback and direction so we know what areas you're interested in for us to test.
So just to make sure I'm understanding that graph, that chart correctly, we're saying we've sent the green line, we've sent somewhere over 2 million packets, but the receiver only got about 1.8 million or so. So we've lost about 10%. Is that about right?
Yeah, that's about right.
Yeah, so one interesting thing I've learned about testing, especially with these cards right here, is you don't run it full bore, because there will be packet loss. So what they do is they do a stair-step test. Now we're just here doing a really quick demo, so we haven't tuned this test for you. But there's a lot of work to do with test tuning. So we have to run the test at exactly where we think the limits are. David, you could probably help me with this better than I can. You go and you stair-step. Like you might do a 1 megabyte per second stair-step until you find the packet loss area. And then you back down and you're going to say, okay, I'm going to run it 90% of where I hit packet loss and run that test for a long time.
Right. And
so there's all sorts of...
That becomes the real throughput of that.
Right. Measured throughput. And that's really where you can tell your application team, I tested this at such and such, line rate with this packet size and didn't get any packet loss. And I did it for a day or a month. So that's one of the great things. You can actually have extended tests run here in the virtual environment. So you're not tying up all that hardware.
Nice.
I want to answer Matt's question that he asked a long time back. Yeah, he asked whether a lot of customers would want to build out a test lab to replicate whatever is in the production. And I want to touch base here as to what Velocity does and the architecture and why OpenStack makes a lot of sense. Because you guys said you have not been deploying OpenStack yourself. What is Velocity and where is OpenStack? Velocity is on the top layer where you can draw out a topology, test topology like this, and then push a button. This is actually a VM. This has the topology. You can save the topology and share it with your colleagues, and they can use the same topology as well. And when you push activate, that's when it talks to OpenStack and starts building out the topology. The other screen that Yuji showed you a few moments back, can you
dashboard?
Yeah, the OpenStack dashboard. This is what you use to manage your cloud. It's not intended to be, this dashboard was never intended to be a test dashboard or network test dashboard. This is just a cloud management system, right? So these vertical bars are the L2 domains, and you have VMs that are connected to this and so on. This becomes a little ugly, and this is very difficult if you're using this dashboard for your testing. And that's where you would have to, you can utilize Velocity, where you can build out a large topology and push it to OpenStack to build it out.
You can save, that's the key thing that I like about Velocity. You can save these topologies and reuse them later. So you can work on all sorts of different topologies, save them in your little index. What's it called? Your catalog, your library. And then you can call them back up later and replay them and rebuild those topologies. One of the things we were doing before Velocity is we would have to build these topologies out either manually, dragging and dropping individual machines and connecting routers. One of the other OpenStack projects that's really popular now is the Heat project. And Heat provides a way to automate the build out of these, but you got to learn coding languages to build those out. So we have also started building out Heat templates for these. If you guys are interested, we can share those.
Coming back to Matt's question, you can point Velocity to either VPTC, our cloud that we built, and we can build a cloud for the customer, or we can point it to your own cloud that you're building, that the customer has built. So as long as it's
not OpenStack?
As long as it supports OpenStack Neutron API. It's fine.
It doesn't.
A lot of customers are starting to build that out with VMware releasing their own OpenStack distribution. That's going to see a lot of changes in the industry. So that's what we're seeing. So the direction of the industry is going.
What do you mean you don't use? It's virtual, but it's not cloud, right? So you don't use OpenStack at all.
Cloud does not mean OpenStack.
I understand.
That's kind of where I'm going with that.
Yeah.
Right? There's plenty of customers that deploy clouds that don't use OpenStack.
Right.
That's where I'm going with it.
So we have the ability to record your whatever APIs you're using. So we have customers obviously who have made clouds 5-10 years ago, and they have their own REST APIs that aren't in any documentation anywhere. So how do you orchestrate that? How do you automate that? Well, we have the ability to record what they would normally do when they deploy VMs, and then edit those recordings and play them back.
Yeah.
So that's kind of a cloud and orchestration, but obviously that's not out there in the market commonplace. So we've chosen OpenStack as a example to show how things can be done, but it could also work with others. And actually, we have a lot of case studies, I think, where we've orchestrated VMware and other Hyper-V, other kind of clouds or virtualizations.
Yeah, because the options there is, and I agree, you do have to pick a platform to start with because you have to show some kind of method. But then, yeah, there's tons of other platforms out there.
And clearly the direction.
You got to get on the mic.
Clearly the direction. What we're showing today is this is an initial first step. We'll definitely be supporting third-party clouds, you know, and customer.
No, I like what he said about the generation, because like with VCAC or something like that, the structure's already been built. You just need like a widget, and you know, a lot of us can build widgets. You know, you don't have to be a software developer per se to do that kind of stuff. So as long as the tools are available, and we say, okay, here's the method with which we create test cases in your gear. Here's basically the snippet that you need to call. That's a lot more consumable from my perspective, right?
Yeah.
Just a bit.
Is there another demo?
Well, we can try to deactivate the topology and see if this goes away.
Okay. We're going to try to set up for the next demo.
Yeah, that is
So one of the cool things I just learned about that we can also orchestrate with iTest, we have drivers. And I brought all these show and tell items up here because, well, first of all, to show how we've decreased the size of our components and made things faster. But these are QSFP to SFP, 40 gig to 10 gig cables that I'm using in the VPTC now. I've had to learn more than I ever thought I would want to know about copper, twin ax, and optical, fiber optic technology, short haul, long haul. I mean, it's mind blowing. So one of the cool things that I figured out we can do, because we've been calling over there and saying, hey, can you unplug this? We have this really expensive test equipment in our colo, and then we have we have a lot of servers. So how do I share this expensive test equipment between many servers? And we've been having them unplug the cables and plugging them in, and I have to file tickets to do that. And I found out we have what's called MRV. Has anyone heard of MRVs? Yeah. Those are so cool. We actually have a driver for the MRV that can do all the cable swapping for you through our API, through automation. And so I tweeted about that too. If you guys are interested in knowing more about that, if you have them or interested in looking at them, it's very, very cool stuff. You guys interested in looking at any of this? We got, these are the 100 gig modules that we break out to 40 with the QSFPs. And you can also plug a 40 gig QSFP in there and break it out to 10. So it's all kinds of fun stuff if you guys are interested. Well, that's the 40 to 40, and this is the 40 to 10, and there's the modules. So, anybody doing 40 gig in their data centers today? One head nodder. All right. Any 100 gig? This is an old 100 gig optic. This is the one we have, I think, maybe Mike 4 years ago or 5 years ago, and now they're probably less than half the size for 100 gig, the new ones.
It's just like a breakout.
Yeah. Oh yeah, this is real. It's really fun working here. I get all kinds of toys. So this down revs the 100 gig interface to two 40 gig interfaces, and then we down rev that even further to 10 if we need to, for a lot of the servers. Intel just had their IDF, and they announced their 40 gig line cards now, that we can start putting 40 gig in servers. Okay, we're ready for the next part of the demo?
Sure, yeah. So I'm not sure if you noticed when I clicked on deactivate on the previous topology on the OpenStack dashboard.
All gone.
Right, all the networks and VMs are gone. So now we're going to try another topology. I named it wrong. It's actually a layer 3 topology because there's a router here. This is actually hooked up to the Nefoscale VPTC cloud. Yeah. So when
Let me just get this straight. So this is where you have a Velocity running here in our building, and we're going out through the firewall over the internet to our Velocity, or our VCT lab in Nefoscale in San Jose. So it's going over the internet?
Yes, correct.
Okay.
Yeah.
And did you already deploy it?
Not yet. So this is the dashboard for the Nefoscale OpenStack.
Right.
All right. So now I'm going to try to.
So you see there's just the public network there that is installed when you first create your OpenStack. We're actually using RDO. Everybody heard of RDO? It's provision your OpenStack. It's Red Hat's free OpenStack deployment tool. So we log into our portal. I request a CentOS box. It takes about 5 minutes. They build it for me on the fly. Again, it's a bare metal box. I can choose from 8 to 256 gigs of memory. I can choose the number of CPU cores, all that, disk space. And then I push a button, it makes the machine. We then use a salt stack script. All of this is part of our blueprint, by the way, if you guys are interested in learning how this works. So we have a salt stack script that deploys RDO, builds out OpenStack on that machine, configures this public network. So we give it a /29 range of IP addresses, and then it's ready to go on to the next phase where we've connected it to Velocity.
So let me try to activate it. And hopefully something good happens.
They say never do live demos, but here we go. Okay, so it's built these networks. We have a management network. That's the first one, the orange one, then the source and destination networks. Now it's deploying the virtual machines and connecting them to those networks. The box there is a router. That's the management virtual router that connects. Go ahead.
Yeah, this is the router that connects to the external internet.
Yep.
Yeah, there you go. This is the DUT, device under test. That's also a router in this case. You deploy 2 Spirent test center virtuals. This to test out this.
Can't hear him? We can't hear you because you're not on the mic.
This is the router that connects the cloud to the internet, and this router right here, this box, is our DUT for this test case. The Velocity has spun out 2 Spirent test center virtuals. Spirent test center is the layer 2-3 testing VM right here.
I think they got that. They're going to be experts in that by the time
Exactly.
they leave here.
And there you go.
All right.
It's acquired the IP addresses, and then it's running the test right now.
And so you asked earlier if we're working with any other companies to test the products and do benchmarking and stuff. So we're hoping that the vendors that make products will come to us and ask us to put their products in this test environment so that you guys can test their products there, right? If they don't want to, or for whatever licensing obligations we can't do that, then you guys can also you can obtain the product, put it in there, and then you can test it. This is all the OpenStack under the hood. It gives you all kinds of logging about building out the VMs, their IP addresses. It injects the SSH key into the Linux box so we can log into it with the SSH key. And it uses Cloud Init to configure the IP address, the host name, and kick off, if you want to do other configurations under the hood, it'll kick off the DevOps tools like Salt, Ansible, what have
So
you.
someone here mentioned about a lot of FUD about virtual routers and virtual networking devices, right? So with this platform, Velocity, what we'd give you is the methodologies. We'd give you the topology. Let's say the DUT, the device is a router. We would give you the topologies that you need to test it on. We'll give you the test cases that you need to run. We'll give you the tools that will generate this test traffic. We'll also give you the devices that it's going to absorb this and analyze the traffic and going to give you the results. So the whole package, the topologies, test cases, the results, and how to analyze it, and give you yes or no. So in a single topology, you can deploy whatever router that you're evaluating and run in the identical platforms. And there you have it. You'll have the results with ranking 1, 2, or 3, whatever you want. So that gives a more uniform or identical way to analyze your virtual devices.
One of the other things that is very important here is that we talked about a lot of when you go to deploy a new firewall or virtual appliance or even any kind of server in a virtual environment, a lot of times they just give it more memory and more CPU to ensure there's no performance problems, but you're not really sure about the tuning. So you can deploy your system, your device under test with various hardware configurations, different virtual CPUs and memory allocations, and see at what performance you get based on the hardware allocation, so you don't over allocate.